We're going to factorise some simple quadratic trinomial expressions by using what is sometimes known as the PSN method. Other teachers use PSF, where F means factors, N here just means numbers. Okay, let's attempt our first one. X squared plus 9x plus 18. We've got to factorise that. And I need 3 bits of data: the product, the sum, and the numbers. Now, the product is found by multiplying the coefficient of x squared by the constant term. Constant's a fancy name for a number that's not attached to a pronumeral or variable. So 1 times 18 is how we find the product. I'll just write that in so you know where it's all coming from. And over here, in example 2, the product's going to be 1 times 21. Okay. Here, the product's going to be, you fill it in later. And later. Okay, now the sum is the easy bit. That is just the coefficient of what I call the x term. So the term that has x to the power of, there's an invisible 1 there. Okay, and it's always just the coefficient of that term, usually the middle term. So in this case, it's 9. In this case, it will be 10. In this case, and in this case, you get the idea. Okay, now the guessing game starts. I've got to think of 2 numbers that when multiplied give me, or whose product is 18, but when added, the 2 numbers together, give me 9. So if you struggle with that a bit, you can just list the factors of the constant term. So it's, what are the factors? 1 and 18, but whilst 1 times 18 is definitely 18, I can't combine 1 and 18 to add them to get 9, can I? What if I try 2 and 9, because 2 times 9 is 18, but 2 plus 9 is 11. So what about 3 and 6? 3 times 6, 18, 3 plus 6, 9. Yep, therefore my numbers are 3 and 6. Okay, so these are expressions, so each line starts with an equal sign. This expression here, this quadratic trinomial, is simply equal to x plus 3 bracket x plus 6. Okay, and that's all I have to do. I can check my answer by using FOIL to expand the brackets here, and I will get back to x squared plus 9x plus 18 once I use FOIL and collect the middle terms. Okay, what about here? Well, we've got the product. It's 21, remember? 1 times 21 is 21. And the sum, yep, 10. So the numbers are going to be, well, 21 doesn't have a lot of factors. 1 and 21 is 1 factor pair, but I can't combine them to get to 10. What about 3 and 7? Yes, 3 times 7 is 21, and 3 plus 7 is 10. So my numbers are 3 and 7. So it's going to equal, it doesn't matter which order I write these in. I could have written a 7 there and a 3 there. It just doesn't matter because of the commutative law of multiplication is what's at play here, so it doesn't matter. X plus 7. Okay, now for 3 and 4, I'm going to do some gestures and to suggest what the answers might be. And you can either pause now and play later or follow along with me. And that will be our video.